I'd also remind everybody that there are previous videos of this material in Blackboard. Probably the latest one will be clearer because it was done at my house, and I've got a whiteboard right behind me. And but you'll probably have to have a copy of this with you when you look at it, because I don't have one of those plastered on the board. Hopefully this will work today. Okay. All right. Let's see. Business. I haven't checked this morning, but as of last night, nobody had done the syllabus test. And you need to get that out of the way. I mean, it's worth 1%. I wouldn't want to throw that amount of a grade down the toilet. So get that one done. And then our exam on this material will be day after tomorrow. If you're here, there'd be a paper exam. If you're not here, I'll enable the Blackboard exam, which is a duplicate actually of the paper. But in order to take the Blackboard exam, you've got to have Respondus Monitor and Lockdown Browser installed on your machine. Of course, for those students, I see one student here who's imported from my web course. You're welcome to join the Zoom class, that's fine. You don't have to, because you signed up for a web-based course. You can work completely through Blackboard. But it's sort of a, I don't know, I think the proper term for this type of course is high flex, which means you can take it just about any way you want to. It's supposed to be designed to be flexible for every type of student. So, for those students that are from the web course, you're probably expecting to take your exams online anyway. So you already know about the Respondus Monitor and Lockdown Browser that have to be installed. You have a those two students have a copy of the original syllabus for the web-based CHEM100. Go ahead and use that one until I get the current one modified so that it includes everything. And then I'll send you a fresh copy of that one. Okay. First thing I do during a review is ask if there are any particular problems that you're having. If you worked some of the problems in the review document and you encountered situations that you could not resolve yourself, then we'll deal with those first. Otherwise, I've got some of these problems picked out. I'm not going to do all of them, but some of them picked out that are representative, and we'll review that way. So is there anybody that has specific problems? Okay. So either you've mastered the material already or you haven't tried any of the problems. Whichever the case may be, let's start with 1, 2, and 3. And we'll do those first. All right, for 1, this is simply unit conversion and understanding what prefixes mean. So the number of milligrams in 6.6 kilograms is test. You've got 6.6 kilograms, you're given that information. Okay. If you want to convert, you can do it. If you do it enough, you can do it in your head. But if you need to put it on paper and be satisfied that you're doing it correctly, you need conversion factors. So this is one in which you may not know the direct conversion from kilograms to milligrams. But if you're like me, you know that this kilogram is 1,000 grams. Right? So you have to cancel the kilograms. Am I writing big enough so you can see that?
Yes, yeah, for me.
Oh, okay. You want to cancel the kilograms and say I don't know milligrams, but I do know grams. And you have, for each kilogram, you have 1,000 grams. Okay. So now I can convert grams to milligrams. So milli is 1,000th of. So you can do it this way. You can say 1 milligram is 1,000th of grams. Or you can say there are 1,000 milligrams in 1 gram. Either way works. So now you notice that this is where we're headed. This is where we started from. And by these successive, what I call chained conversions, you can eliminate the units that you don't want and change them into the units that you do want. So now, that's the thinking part. The rest of it is number crunching. So if he has 10 to the third and 10 to the third, that's 10 to the sixth, correct? Right, just add the exponents. And then 6.6. Because we didn't have any other coefficients in here to multiply or divide that by. It's all by itself. There's just 1 there and 1 there. 10 to the third, 10 to the third, 10 to the sixth. So 6.6 times 10 to the sixth milligrams is the answer right here. Okay? All right, we're going to move on to number 2. So just read the problem through and then ask, what's the question? Water has a density of 1 gram per milliliter. For our purposes, that's close enough. Which of these objects will float in water? Okay, the question is, to be answered is float. Which one floats? You have to understand that anything that is less dense than the fluid that in which it's immersed will float. So anything with a density less than 1 will float. Anything greater than 1 will sink. So which of these objects will float? You don't actually have to do a longhand calculation here. You can estimate, that's close enough. And I'll show you how that works. If this is your target, that's the density of water, and anything less than that will float, then you look at object 1. You have 50 grams in 69.4 milliliters, correct? So is that greater than 1 or less than 1? Less than 1, isn't it? The denominator is bigger than the numerator, so that one will float. It's less than 1. This one is 69 divided by 54.7. 60.9 divided by 54.7. That's greater than 1. That one's going to sink. And then this one is 100 divided by 40. That's greater than 1. So the only one that's going to float is the first one, Roman numeral 1. Here. Okay? Right. Every student instinctively knows that the less time you take on a problem, the better off you are. As long as you know what you're doing and you get the right answer, then short amount of time is better. So we just took a shortcut here. To answer the question, you don't have to calculate the whole thing. You just have to know whether it's greater than 1 or less than 1. That's why I did it that way. Let me scroll down to, let's see, maybe I can do it this way. No, too far. There we go. So 3 is just a simple conversion of temperature. So we're starting off with minus 12.2 degrees Celsius, and we want to go to Fahrenheit. So you need to know the conversion formula for temperatures. And that information is in the back of your review document, which means it'll be, if you're here in person, it'll be in the last pages of the paper exam. Let's see, there's the formula. All right. If you take it online, then what you need to do is before you go into Lockdown Browser to start the exam, you need to go into your browser, go to the exam folder, and print off the useful information document. I have one of those in every exam folder has one of those. The reason you need to do it before you do lockdown is because lockdown is just what it says. It locks you out of everything except the exam. So you won't be able to access that information unless you do it before you take the exam. All right, so what's the formula? Well, this is the way I memorized it. Degrees Fahrenheit equals 9/5 C plus 32. 9/5 is 1.8. Okay, is that arranged the way we want it? Well, yeah, we know this one and we want that one. So we can leave the formula alone, just like it is. And just plug in the number here, minus 12.2 degrees C, right there. Okay, so you just need your calculator. And don't forget that minus sign. 12.2, change the sign. And then times 5 by it, okay. And then plus 32. So I get 10.22. Fahrenheit. Significant figures. Right? This is a constant value. It's an exact number. It has no impact on the outcome. You only have to look at how many were in the original. So you have 3 significant figures here. You can have 3 here. So it's actually 10.2 degrees Fahrenheit. Okay, so we look over here. All right, this is a good illustration of if you don't see the exact answer you got, pick the best answer. 10 degrees Fahrenheit. If you have a choice here that says none of the above, then you're perfectly justified in picking none of the above here because you just calculated this and it's not there. But since you don't have that choice, then pick the best one. All right, so let's see what's next. We're going to skip down to 7. So it looks like this one is another temperature conversion, but it's going the other direction. So 232.0 degrees Fahrenheit, 232.0 degrees Fahrenheit. And the formula I memorized is this one. So you have 2 choices. You can either plug the number in here and solve the unknown, or you can go ahead and solve the formula and then plug in the number. So I'm going to solve for the one that I want. I want to solve for that one. So this has to come over here. Right? And then this flips times that. Right? And then we put in here 232.0. So I get 111.1111 degrees centigrade. Okay, so again, we have 4 significant figures. We can stop it here. Now, is that one of our choices? Yeah, in this case, it is. The exact value that you calculate. Let's see, next I want to do number 9. Let's see, let me scroll that up just a little bit. Okay. There we go. Okay, which of the following describes a chemical property of gold? So here you have to understand what we mean by chemical properties versus physical properties. Chemical property is the potential to undergo a chemical change. So some descriptive term or descriptive value, sentence, whatever the case may be, describes a property of gold that pertains to a chemical change. So which one is, I don't have to write these up here. Gold is a very dense metal. When we're talking about density, that's a physical property. Has nothing to do with chemistry. Gold is a soft metal. That's a physical property. Gold is an inert, non-reactive metal. Okay, there's your key. Non-reactive. It doesn't react. That's a chemical property. You can look at the others. There's color, good conductor of heat and electricity. That's a physical property. So C is the only answer that actually fits really well with that statement, chemical property. All right, let's look at number 12. All right, significant figures. So which rule is this? There are 2 rules for significant figures calculations: add, subtract, or multiply, divide. This is obviously add, subtract, 54.34. So how do we do that? We line up the decimal points. 4566. Right? Then just add them and keep all your decimals to begin with. So 6 and 4 is 0, carry 1. And that's another 0, carry 1. That's another 0, carry 1. There you go. So this, as written, can we keep all those decimal places? For add, subtract, yes, we can. Because that's significant. That's a significant figure. That's a significant figure because they're non-zero numbers, actually. So that's significant. That means we can keep this one. So the mistake that's made is using the wrong rule. Students want to use the multiply divide rule all the time because it's the easier one. You just say which one's least. Well, you should say, well, they both got 4, so we should be able to have 4 down here. Doesn't work that way for add, subtract. You watch the decimal point. So we have 5 significant figures in the answer. Right here. Well, I chopped it off, but it's D. Okay. That was 12. Let's see here. There. And we're going to 15. Which of the following is an element? Alcohol, salt, helium, sugar, vinegar. And an element is, number one, it's a pure substance. Right? You can't reduce it any further. But compounds can be pure substances too, so that's not enough. An element is a pure substance when reduced to its most basic part is an atom. So if we reduce alcohol to its most basic part, it's still a molecule. Salt, reduced to its most basic, is an ionic compound of sodium and chlorine. Helium, there's your element. If you subdivide helium down to its most, its simplest form, there will be one atom of helium. That's an element. Sugar is a molecule. Vinegar is actually a solution of acetic acid in water. So helium is the only one that satisfies that. Now, the other way to tell if it's an element is just look on the periodic table. Is it there? Right? You're not going to find alcohol on the periodic table. You're not going to find vinegar up there, or sugar, or salt. You will find helium. So that's another reason to memorize those things I gave you. Memorize those symbols so you'll know when you have an element because it's up here. Let's see, let's go to, turn the page. 18. Okay. How many liters are in 29-ounce bottle of pop? 29 ounces is given. 29, that's it. Okay. So what we've got to do, we're given 29 ounces, but they want to know it in the metric system, the volume in the metric system. So you've got to make the transition from the English system to the metric system, and then perhaps even change the metric value. So what do we have up here? You're given these values. Right? We can do ounces to quarts. Here you need to recognize that in equivalence generates a conversion factor. So if you've got 1 quart equals this many ounces, we can convert that to quarts. Now that's not going to get us to the metric system yet, but this one will, because this one converts quarts to liters. So we need a chain conversion. And our first one takes care of the ounces and gives us quarts. So we've got 32 ounces is 1 quart. All right, so the ounces are gone. Now we've got to convert quarts to liters. So 1.0567, 1.0567 quarts is 1 liter. Okay. Our thinking's done. All that's left is number crunching. So we'll take 29 ounces, and in your calculator, all you have to do is say, this is in the numerator, so that times that times that, then divide that, and then divide that. So 29 times 1 is what? Let me think, 29. Divided by 32, and then divided by 1.0567. So I get 0.8576. Liters. Can I keep those? No. These are exact numbers because they're conversion factors. You don't have to worry about those. But look to the original. This is a multiply rule. There are 2 here. That means I got to round this one to 2. So I'll look right there. That's greater than 5. This means 0.86 liters. Right there. I think we're going to 20 next. Yep, 20. Let's scroll down a little bit. Oops, too far. Let's see, what's after 20? 22. I don't know if I can get, I can't get both of them on here at the same time. So we'll just take care of 20 and then scroll. Okay, which of the following is a homogeneous mixture? All right, the question is, homogeneous mixture, I would start from the end and work backwards. Which ones are mixtures? All right. Gasoline, yeah, that's a mixture. Copper metal, no, it's pure substance. Throw it out. Jelly beans, yeah, technically that's a mixture. Pure water, nope, throw it out. Soil, definitely a mixture. So you can throw out the pure substances and then decide which one is homogeneous. Well, jelly beans obviously aren't homogeneous, right? All you have to do is look at a jar of jelly beans and you'll see the color distribution is not the same throughout. And soils are, well, take my word for it, they're heterogeneous. So the only one that works is gasoline. That is a true homogeneous mixture. And what's another word for homogeneous mixture? Solution. Gasoline is a solution. What did I say? 22? 22 is next. Okay. Get a drink. Wet my whistle. All right. A graduating cylinder contains 20.0 milliliters of water. An irregularly shaped object, let's see, I'm scrolling off the end, is placed in the cylinder. And the water level rises to 31.2 milliliter mark. If the object has a mass of 80.4 grams, what's its density? Okay, read this one backwards. The question is at the end, what's the density? So how do you calculate density? Mass divided by volume. And then you also look at your answers. What are the units of the answers? Grams per milliliter. Okay, so you need to have your mass in grams, your volume in milliliters. Is that going to happen? Well, yeah, grams here and milliliters there. So we're good to go for the units. So what's the mass? 80.4 grams. That's given. 80.4 grams. How do you find the volume of the object? Well, if your cylinder had 20 milliliters of water in it to start with, and you submerge an object completely, submerge it, it will displace its own volume as long as it doesn't absorb water, as long as it doesn't react with water. You can't do this with something like a chunk of sodium or a chunk of potassium. You put those in water and you're going to get a violent reaction, so that won't work. So you would need something besides water, right? So this works with water here, but you could do it with, say, with sodium. You could use oil and measure the volume in oil because it won't react with oil. But in this case, the object caused the volume of water to go from 20 to 31.2. So the volume change in volume is 31.2 minus 20, right? The final minus the initial. And that value is, let's see, 11.2, right? Milliliters. Yep. Okay, so now we know the volume. That's the hard part. Now you just crunch numbers. So I get 7.17857. Grams per milliliter. Got 3 here, 3 there. All right, did we do this right? Yep. Lined up the decimal points. We're good there. So it's 3 here and 3 there. That means we can keep 3 here. 7.18. Right there. Now it's 22. Let's see. 25 and 26. Let's see if we can get those together on the screen at the same time. We're going to need to move over a little bit. Okay. What's missing out here? A little bit's missing. $25. What Kelvin temperature? 25. What Kelvin temperature reading equals 61.2 Fahrenheit? Can we convert Fahrenheit directly to Kelvin? Well, no, because Kelvin is based upon Celsius. So you can convert Fahrenheit to Celsius first. So if we've got Fahrenheit equals 61.2 degrees Fahrenheit, and we want to go to Kelvin, then we have to convert that. So we know that the formula here is 9/5 C plus 32. In this case, I'm just going to plug in 61.2 here, right? And then solve for C. So 61.2 minus 32 is 29.2. And then I'm going to multiply by 5 and divide by 9, right? Because this over here flips on its head. All right, so this is 16.22222. Now this is, before we can go to calculate K, we're going to have to decide how many significant figures you got here. Because this is done. Now we've got to use a different formula. So we do have to round before we go to the next step. So these are exact numbers. So we're basing it on this one. So we have 16.2 degrees C. Now, what's the formula for K? Well, K equals C plus 273. Actually, we could do this, 0.15. You don't have to. The answer is probably going to be the same no matter what. But 16.2, then we put in here, and we add 273. So I get, we line up the decimal places. Okay, so we can only keep one decimal place anyhow. And we get 289.372. So we should be able to go 289.4. Okay. Let's see, is that up there? 289.4, there you go. Right there. If we had used 273 here, then it would have come out 289.2. So in that case, you just pick the best answer. Okay? '25, '26, I think is also one of my picks. '26. Yeah, this one scrolls off the end, I think. Yeah. So I'm gonna look at the hard copy and see. No, that's good. That's good. We can read it off the board. Which of the following processes is a chemical change? All right. The change is no longer chemical property, is potential. The change is something actually happens. So when dry ice sublimes, what's that? That's just a phase change. That's physical. The light on a candle burns until a bell jar is placed over it for a period of time. That's a chemical change. The wax in the candle is being melted, migrates up through the wick, turns to a gas and mixes with air, and then combusts. That's a chemical change. Okay. When a few drops of red food coloring are added to a beaker of hot water, the water immediately turns red. That's a physical change because no bonds were broken, no bonds were formed. Liquid nitrogen dumped on the floor vaporizes at room temperature. That's a change, a phase change, physical. None of the above. All right, we did find one, B. So B is the answer to 26. Okay, let's see, skip to number 30. Let's scroll over in case. There we go. Number 30. Which metric prefix is used to designate 1/10? So this is simply a memorization. So what's 1/10? That one right there stands for deci. Now, in the medical profession, deci is used a lot for blood tests, urinalysis, those types of things. They'll come back so many nanograms or so many milligrams or so many units per deciliter. That's very common. They use that measure because it gives you a number that's usually between 1 and 100. It's right in that. It's purely for aesthetics. They could use any measurement they want to, but doctors are trained to read these reports in terms of deciliters, usually. What about the others? That's just why we're here. What's M? That's mega. And that's 10 to the 6th times. How about K? That's kilo. That's 10 to the 3rd times. How about C? C, centi. That's 10 to the -2 times, or 100th. M, milli. That's 10 to the -3 times. Okay. All right. Now for 30. Let's see, 30, and we go to 36. And scroll over a little bit. All right, we can back it up some. We need that density. There we go. 36. The volume in milliliters occupied by 41.9 grams of mercury is what? So what are we dealing with here? Density. This is the mass of the mercury, and we're looking for volume. So the relationship here tells you the controlling formula, density. Okay, so we're given mass and we're given density, right? We're given this one, we're given that one, so we can find that one. So let's just solve for that. There we go. So now we can put the mass in, 41.9 grams, and the density is what? 13.6. By the way, how much denser is mercury than water? 13.6 times, because water is 1 gram per mil. That's also known as specific gravity. 13.6, just the pure number, means mercury is 13.6 times the density of water. So we just need to solve that one, right? Multiply, divide, so we can keep 3 significant figures in our calculation. 41.9 and then divide it by 13.6. So 3.08088. All right, we got 3, so we can draw the line there. That's a 0, so we get to keep 308 grams per mil. Oh, excuse me. I worked too fast. I didn't pay attention. This is in the denominator, that's in the numerator, right? But the denominator of the denominator is the numerator. So this milliliter now comes up here. Okay. So now we can find our answer here. 3.08 milliliters is the volume of mercury that will give you that mass. Let's go down to 40. Let's see how we're doing on time. Coming up on 9 o'clock. Okay. We got 45 minutes. Number 40. How many significant figures are in this number? All right. You just need to know the rules. 0.004 0090. Right. So here you're looking at the 0 rule, and you got all 3 types of zeros here. You got zeros to the left, captive zeros, and zeros to the right. So are these zeros significant? Nope, they're not significant. Captive zeros, yep, they're both significant. And zeros to the right, when are they significant? When there is an explicit decimal in the number. There you go right there. That's significant too. So we have 1, 2, 3, 4, 5. 5 significant figures in that number. Another way to tell is write that as scientific notation, right? 1, 2, 3, 10 to the minus 3, and then 4.0090. So you have 5 significant figures in your coefficient. That also answers the question. Number 40. Let's see, 41. It's already up there. All right, we got another memorized prefixes. Prefix that corresponds to a factor of 10 to the minus 2. We did that one earlier, didn't we? 10 to the minus 2 is centi. Here. 100th. So in a centimeter, that's 100th of a meter. So how many centimeters are in a meter? Well, there should be 100 centimeters in a meter. Okay, 41. Turn the page. 47. There we go. The result of the following calculation has how many significant figures? All right. This one is more complicated, and it has a combination of add, subtract, and multiply, divide. Notice we also have parentheses in here. So PEMDAS says you do parentheses first. Whatever is inside the parentheses, you do that first. So inside this parentheses, you have an add, subtract. Right? So we have, I'm going to write this up here first. Just put it all up on the board. 0.4333. And notice we're only interested in significant figures. So I don't need to put the units in. We're just working with the numbers. And then inside this one, we have 33.12, right? And then we're going to subtract 31.12. So we're going to do inside the parentheses here, and then apply it to the rest of it. 412.1. Okay. So this is going to be, line up the decimals. This is going to be 0, 0, 2. Okay. So we got 3 significant figures here. We've got 4 there, and we've got 4 here. This is multiply, divide rule. This is the smallest number. That answers the question. 3 significant figures in your answer. Okay? If we didn't have those parentheses in there, then we would take the order and use PEMDAS, correct? Right? We would do no parentheses, no exponents, multiply. So if we didn't have the parentheses in there, we would multiply here times that one, and then we multiply this one times that one. Then we would subtract. So the parentheses are essential to getting the right answer here, or getting the answer we expect. If you just write those numbers in a string, then you're going to get a completely different answer. All right, 47. What's next? Turn the page. 48. Okay. Homogeneous mixture. Can we just do one of those? Which is an example of a homogeneous mixture. Okay, we'll do another one. Right, we already know. I got something popped up on my screen here. Here we go. We already know that soil, or they're saying soil and dust. They're 2 different things in my world, but that's okay. This is heterogeneous. Sodium chloride is a pure substance. It's a compound. It's an ionic compound. That is an element, right? So the first 3 of them are well, okay. Let me back up. Follow my own rules. Do the mixture first. What's a mixture? That's a mixture. That's a mixture. That's a mixture. So aluminum and sodium chloride, throw them out. They're not mixtures. Now we can go to homogeneous. All right, that's heterogeneous. This is homogeneous. And that's heterogeneous, right? Oil and water don't mix. So no matter how much you mix them, they're going to separate, which means you're never going to find uniform composition throughout oil and water. So vodka is primarily a mixture of water and ethanol with some other things in there. Right, so that's the homogeneous mixture. That is a solution. Let's see, what's next? Turn the page. Turn the page again. There's a lot of repetition in this review document for a reason. 68. Okay. A cubic centimeter, cm cubed, is equivalent to what other metric volume unit? I told you this in class. All you have to do is memorize it. This cubic centimeter is exactly equal to 1 milliliter. They're equivalent in size. So anytime you see a measurement that's quoted in milliliters and you need cubic centimeters, just change the units. That's all you have to do. Or the other way around. If you've got cubic centimeters and you need milliliters, just change the units from cubic centimeters to milliliters and you're good to carry on. So it's right there, C. Oh, excuse me, milliliter, not millimeters. Milliliters. Millimeter is a length. Milliliter is a volume. Okay, 71. Let's see, did I check everybody in? 1, 2, 3, yep. Okay, I got everybody covered. 71, did I say that? The state of matter for an object that has a definite volume, but not a definite shape. You just have to memorize it, right? If it's got a definite volume, it's either a solid or a liquid. And if it's got a definite shape, then it's a solid. So it has to be a liquid. Right here. Now, that could be a pure substance or it could be a mixture. Right? Doesn't matter. This only references those two characteristics, volume and shape. And it applies to any form of matter or any type of matter, whether it's pure substance or a mixture, compound, element, doesn't matter. It refers to any of them. Let's see, 71, 84. I think I picked 84 because it has a picture with it. Okay, let's scroll to the side here a little bit. Let me see if I can shrink it just a hair. Try it again. There we go. Should still be able to see the letters, I hope. Okay. What we're going to do here is take 20.0 milliliters of water from a graduated cylinder. So for whatever reason, and the accuracy of the graduated cylinder is determined for us at 1/10 of a milliliter. Well, actually, it can have markings at 1 milliliter, and the 1/10 is a guess, correct? 20.0 milliliters. So these are certain, and this is uncertain. Okay, now we're going to add that to this beaker, and we're going to say, what are we allowed to call the final volume? So we've got this one, and then we've got this one, so we need to read this one off the, so we can have the certains are in the 10th position, right? It's either 10 or 20. So it's between 10 and 20, which means that's certain, and the ones are uncertain because there's no mark on there for ones. So we would estimate 15, right? 5 milliliters in between there. So 15 is our estimate here. So this is the uncertain. That means we add this one to this one. And we have to call it right there. That means we can only claim 35 milliliters because this is the least certain of the two. Well, we just use our significant figures rule for addition and subtraction. And we can only say 35. You can't say 35.0 because this will not give you an estimate in the tenths, in the 0.1 range. Okay, that's why C would be wrong and D is the correct answer. Okay, that's 84. Let's see, 94. Let's boost this back up. $94. All right. Which of the following is only a physical change? Okay, so what's that saying? Also, look at the answers. E is at least 2 of the above exhibit only physical change. So that means we got to look at every one of them in order to eliminate them and maybe take this one as an answer. So which ones are physical change? Leaves turn colors in the fall. You could argue that that is a combination actually of physical and chemical changes. A banana ripens. That's definitely a chemical change. Cookies burn in the oven. That's a chemical change. Sugar dissolves in coffee. That's only physical change. You're changing sugar from a solid to an aqueous, a solute in an aqueous solution. So that is purely a physical change. So E can't be right. There's only one physical change in that group. It's D. 107. All right. This is definition time. A blank is a summary of observed behavior, and a blank, a something of behavior. Did I get them all on there? Is an explanation of behavior. Okay, it didn't make any sense without that extra statement. So which one is a summary of behavior? It's just a law, right? It says nothing about why. So the one that says law in the first position is a candidate. It's either this one or this one. Law is first. How about this one? And a blank is an explanation of behavior. That's a theory. So it has to be this one. Law and theory. All right, 114 next. Your friend is 5 feet, 9.8 inches tall. What's your friend's height in meters? Okay. So notice that in the English system, it's so messed up. The units of measure related to one another, just off the wall. 12 inches in a foot, you know, where's the logic in that? There's no logic in it. Well, maybe there was historically, but not anymore. So 5 feet, 9.8 inches. Before you can convert to a single unit, you got to get these into a single unit. Right? So this is going to take several steps. We're going from 5 feet, 9.8 inches, and we want to go to meters. Okay. So we got to get this into a single unit. Well, I think the easiest way is to make all these into inches. So 5 feet would be how many inches? 5 times 12, correct? 12 inches in a foot. So that's 60. $69.8 inches. Let's write inches. Okay. Now we can start converting. Right? Do I know a direct connection between inches and meters? Well, yeah, as a matter of fact, I do. 39.36. But suppose I don't remember that. And instead, I remember inches to centimeters. I know that 1 inch is 2.54 centimeters. Okay. Now we're in the metric system. So how many centimeters in a meter? 100, correct? Now we're good to go. So we just crunch the numbers at this point. 69.8 times 2.54 divided by 100. So I get 1.7729. Meters. Right? These are exact numbers. We can keep 3. So 1.77 meters. Let's see, is that one of our answers? They're saying 1.8. I'm thinking, oh, 5. All right, I understand. 5.0 times 12, we can only have 2 here. So that would have to be rounded off. All right, they're correct, 1.8. But that's the best answer. I calculated this, that's the closest one. So since there's no, since you don't have the opportunity to say none of the above, then that's it. Now, if I grade a paper, it's going to be kind of hard to do if you take the test online. But if you grade it in person, then I grade it and give it back to you, and you say, right, if you have the choice to say none of the above, and I think it should be that answer, then you've got a chance to argue your case and say, well, you know, based upon these significant figures here, then there should only be two here through this series of calculations. You can argue your point, then you might win that argument. But if you just say, I think the answer is wrong, and I say why, you said I think so. Well, that's no argument. You got to be able to make your point. All right, so let's see what's next. 114, we ought to be getting close. 116, good on time. Okay, we're good on time. 116. Which of the following is an incorrect description? So we got to read all of them. Oops, my batteries are dead. Pause for a change of battery. Yeah, they're dead. Okay. One 16. Which of the following is incorrect description? So we've got to look at every one of them. Do these descriptions, do the descriptors complement one another, or do they contradict one another? So if you got a mixture, can it be homogeneous? Yeah, it can be homogeneous or heterogeneous. So that was true. How about an element? Can it be solid? Oh yeah. In fact, most elements are solids. How about a solution of gases? Is that true? Yeah. You breathe a solution of gases every day. A mixture of solids. Yeah. Think of an example. Brass is a mixture of zinc and copper. How about compounds and heterogeneous? Does that figure? No. Heterogeneous only applies to mixtures. A compound is a pure substance. It can't be a mixture. So E is false. That's the one that's not correct. All right, that's 116. How about 119? Okay. Using 0 as your reference point, how much liquid has left the burette? Use the correct number of significant figures. Oh, we need a picture. I must be off screen. Hold on a second. Yes, there it is. Okay. Let's go down a little bit where we can see it. All right. So remember, a burette is read from top to bottom. It's not like a graduated cylinder that is calibrated from bottom to top. Graduated cylinders are calibrated to contain. You'll often see sitting on the side of it say TC, to contain. That's how much liquid is in the cylinder. Burettes and many pipettes are calibrated to deliver. So they have a little TD stamped on the side of them. So this is calibrated to deliver, which means if you start at 0 and you go down to here, it has delivered that much. So let's see if we can read this. So there's 0, 10. So that means each one of these is a unit of 1 milliliter, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we go down to 20, and this is 21, and that's 22. So I'm thinking it's sitting, there's 1, 2, 3. It's sitting between 1 and 3, but it's right on the 22 mark. Right? So there's a mark for the one's position. That means we estimate the next one. So if I think it's sitting right on that one, on that 2, then I estimate the next one as 0. So now I got to scroll back over for the answer. Let's see. Oh, it's down. There we go. So in that case, the answer is D, 22.0. If you say the answer is 22, you've actually thrown away information. And if any scientist looks at your value, they're going to say, without that one, that is uncertain. You don't know if it's 20, 21, 22, 23. What? You're just guessing at the last one. But this one says those two numbers are certain. You know it's 22 point something. $119. Let's see. $124. And it looks like it's got some information over here. Let me scroll over. Okay, back up. There we go. 124. Aluminum has a density of 2.7 grams per cubic centimeter. Notice that this is, when it says grams per cubic centimeter, that usually means solid. If you say grams per milliliter, which would be the same number, but it's referencing a liquid, more than likely. So this solid is a density of 2.7 grams per cubic centimeter. Is that going to sink or float in water? It's going to sink, right? I mean, that's not the question, but I'm just saying. It's going to sink in water. What will it do in mercury? Remember, mercury is 13.6 grams per cubic centimeter, or grams per milliliter. It's going to float in mercury. Okay, let's finish this one. What is the mass of a rectangular block of aluminum measuring 11.1 by 22.2 by 34.5? So you have to do two calculations here. One, we recognize that density is the key. Right? If we want to know the mass, we've got the density, 2.70 grams per cubic centimeter, but we need to know the volume. But all we have is the dimensions of the block. If it's a regular block, like it says here, then all you need is height, width, and depth. Multiply those three together. So 11.1 times 22.2 times 34.5. And that'll give you cubic centimeters, right? Because each one is centimeters. And in sciences, well, in math, actually, if the number has a unit, the unit has to be multiplied too. So this multiplies these numbers, but you got to multiply that times that times that. So that gives you cubic centimeters. Now we just need to multiply those three numbers to get the volume. So 11.1 and 22.2 and 34.5. So I get 8,501, 8,501.49. So let's multiply, divide, that means 3. So I can keep 3 of these. That place, 8, 5, 0. Well, actually, this is multiply, divide, and that's multiply, divide. So you can keep all of them until you get to the end, right? We've got 3 significant figures here. And we've got 3 significant figures there. Right? So we can keep 3 significant figures in our answer. But to avoid rounding error, if you don't have any add, subtract mixed in here, then you can just keep them all to the end. Right? So we can take this whole number right here and put it right there. So that means this times that equals mass. So I can take this number times 2.70. Now that gives us 22,954.02. And that's going to be grams. So now we round it off to 3 significant figures, right? So we can go here. That's 22. Wait a minute. It wants the answer in kilograms, correct? Let's convert to kilograms first. So how many grams in a kilogram? 1,000, right? So if we go 1, 2, 3, we have 22.95402 kilograms. Now we round to 3. So this is 5. That means this one becomes 10, and that's 23.0 kilograms. Right here. Okay, that was 124. Let's see here. How are we doing on time? I got 10 minutes. Let's see how many more we got to do. Well, we got several. I might have to skip 1 or 2 and okay, we've already 132 is just a temperature change. We'll skip that one. We've done 134 before, volume by displacement. How about 138? Here we go. Which of the following is not a step in the scientific method? Well, let's see. Let's work from bottom. Hypothesis. Is there a hypothesis in the scientific method? Yep. So E is correct. Make an observation. Oh, yeah. Everything starts with observations. Perform an experiment. Oh, yeah. You have to test. You have to test your hypothesis. Right? B, develop a theory or a model. Ultimately, yes, you do. An intermediate step might be a law, and then you're trying to figure out why does it work. So yeah, B is reasonable. How about A? Change results to agree with your hypothesis. Yeah, you can do it, but just don't get caught. If you get caught by your peers or by the editors, your career will end in a hurry. That's called falsifying evidence. And my way of thinking, I think there are a lot of climate scientists that are doing just that. They don't, actually, the way you change your results in climate science is you change your model. You change your model so that when you put in the variables, it spits out the number you want. That's why none of the climate models that have been used over the past 50, 60 years, none of them work. They have not been able to predict actual temperature changes that we've observed in the interim. So in my way of thinking, a great many climate scientists are guilty of that one right there. All right, 138, let's see. How about $149? Let's see, 149, let me scroll over a little bit. There we go. How many of the following are compounds? What do you need to have to be a compound? You need to have 2 or more elements. Bound in a single unit. Now we're talking about identity. Because each of those elements has its own identity when it's not associated with anything else. And if the identity of the substance changes, when you put these 2 or more elements together, then you have a compound. If you put those 2 together and the identity of the components doesn't change, you just have a mixture. Right? So which satisfies here? Right? You got 2 different elements there in the molecule of water. Here we have dinitrogen tetroxide. Here we have sodium hydroxide. Here we have manganese dioxide. Actually, that's manganese 4. We'll get to that eventually, naming compounds. And there's hydrogen fluoride. Those are all compounds. Right? 1, 2, 3, 4, 5. 5 compounds. What about this one? That's only 1 element. I mean, there are 2 atoms together, but that's not a compound. That's a diatomic element. All right, 149, let's see. Let's do 156, and that'll be the end of it. 156. That'll be the end of our review, in other words. There we go. 156. Which of the following is an element? All right, which of the following is an element? All right, remember what we said. If you subdivide the substance and you have single atoms left over, then you have an element. If you break this one down and it's still water when you get to the end. What you have here is a water molecule. That's not an element. Earth, well, Earth is a mixture actually. So eventually you get down to, you might get down to elements, but you're gonna have different elements. So you can't say Earth is an element. Right? It'd have to be just one single atom all the way through the Earth. That won't happen. Salt. Salt is a compound of two different elements. How about brass? Brass is a mixture of copper and zinc. Oxygen. Oxygen is an element for the reasons I've said. Also, it's on the periodic table. That's probably the easiest way to determine element, right? If you got a name here and it's on the periodic table, there you go. It's an element. All right. So that's our review, and we'll have an exam day after tomorrow, one form or another. If you want to come to class, I'll have paper copies available. If you take it online, of course, you'll have to be sure that your Respondus Monitor and Lockdown Browser work. So if you do that, go into Blackboard and be sure that you have both of those available to you. Look in the syllabus. It'll tell you where to go to get the copy of Respondus that is keyed to New River. If you don't go to that exact website, then you won't get it on your computer. It won't be licensed. And then there's a practice test in there in Blackboard. And that all that does is just that makes certain it steps you through the same stuff you go through an exam, and it makes certain that all your equipment is working. So you want to do that before you take the exam. Otherwise, if you try to take the exam without doing the practice test, then once that practice test starts, you're in it till the end. Okay, let's see. We still only have 3. All right. That's all I have for today, and I'll convert this to a video and just see if the quality is any better than than I expect. Hopefully it is. Okay, any questions?
Just one quick question.
Okay.
So for the useful info document, where exactly do we find that?
That's in Blackboard.
Okay. Because I was looking and I couldn't find it. Like,
Couldn't
what
find it?
exactly?
Okay. Let me do it on the other computer so it'll show on the screen.
Okay.
So we're going to go down to Module 1. And then we need to go down, scroll down to Exam 1. There's the useful information right there. Can you see my pointer?
Yeah, I can. Thank you.
Click on that. Oh. Okay. That needs to be corrected. That's where it will be. As soon as I put it there. I thought it was, when I just copied the course over from a previous course, I thought it was already there, but obviously it's not. So it'll have, and that's where you need to go before you go into the Lockdown Browser. It'll have, there's not a whole lot on that page, right? You have just those 2 things at the bottom. Let's see. Or if you don't want to go to all that trouble, just go into Blackboard and get the review document. Right? And take that last page. And if you're using more than a review document, the respondent is going to pick it up anyway, and I can see the eye in the sky is watching you. So I will fix that. As soon as we hang up, I'll go and fix it right now. Anything else? No? Okay. Well, maybe I'll see you on Thursday and maybe I won't. But I'll be here in case anybody wants to come in and take the paper exam. If you take the paper exam, I'll grade it on the spot and give it right back to you. Okay. Bye-bye.